Determine the coordinates of the point xy after a reflection across the x-axis. So we're going to be reflecting across the x-axis, and they're saying to reflect any point of this form. So since we're dealing with letters, so we're trying to come up with a rule to reflect across the x-axis of a point with this format. So since I'm starting with an x and y, then my answer is going to be some type of an expression in relation to this. So this right here, think about it in terms of any point. So if you reflect any point, it doesn't matter where it's located. I want to know if we could come up with a rule to figure out where the new coordinates will be after we reflect it across the x-axis. So we're going to see, if you start off with an x and y value, where does that point go to? Right, where are the coordinates going to be? So to help out with this, what I usually do is I'll draw a quick sketch. So I'll draw a quick sketch. Here's my x-axis, here's my y-axis. And what I'm going to do now is I'm going to kind of experiment what's going on here. So I'm going to plot a point. Let me plot a point right here. And again, this is just random. I'll pick another point after so you can see. But I'm just going to start here, and this is quadrant 1. If I plot a point in this quadrant, or anywhere in this quadrant, the coordinates is going to be x and y. Right? The x value in this quadrant, all these x values are positive, so I know my x is going to be positive, and all my y values, right, I have to go up to plot the point, will be positive as well. So any point in this quadrant, doesn't matter where it is going to be positive, because you have to go to the right and then up to get into quadrant 1. So positive, positive. And then it says to reflect across the x-axis. So if I'm reflecting across the x-axis, that's this axis here, then that means that whatever this distance is going to be the same distance when I reflect it across to the other side. So I want to go this about the same amount, since this is just a rough idea, just a sketch. And now I want to see, okay, what happened to the coordinates of this point? So I want to know, what are the coordinates of that point? So if you look here, this is my x value. So what happened to the x value? If I have a point here and I move the point down here, you got to ask yourself, did my x value change? Well, this is the x value for the points, and you can see here that both points have the same x value. The x value does not change, right? If I shift this point down here, it's still the same x value. So I'm going to put x here because that did not change. It's the same exact value. And then next, I want to see what happens to the y values. So if you look at the y value for this point, well, that'd be over here. I can see y is positive. That's a positive y value. And then I look at the y value for this point. Well, this here is a negative value, right? The y value is negative here. So I can see when I start from here and I reflect it across this way, the only thing that's changing is the y value, because I'm starting here, which is positive, and I reflect down here and I can see my y value is now negative. So what I'm going to put here is that the y value actually changes to the negative y value. Right? It became, think of it as became the opposite, right? It was positive and now it became a negative. So if I reflect it across, the value that's going to change is my y value. So in my rule up here, I can say each point, or each original point, is going to move to a location such that x is the same and y becomes the opposite. And one thing you can do to verify that this works is, because you may be wondering, what happens if I started down here? So let me draw that situation. Let's see if that rule that we did applies, if it works. So let me put my y-axis, here's my x-axis, and I'm going to start with a point. Let's just make up a point. I'm going to say this is the point -4, and I'll make this about -3. So here's my -4, -3, and I'm going to reflect this point -4, -3 across the x-axis. So if I look at this distance here, this distance is, how far is it from the x-axis? Well, this is a distance of 3. From 0 to -3, that's 3 spaces apart. So I know this is 3 units, so I have to go up that same amount. So I have to go up 3 units also in this direction. So I can see that my x value here is going to be 3, because I have to go up the same distance apart. That happens with any reflection. And that's my new location. So let me just give this point a name so I can see this is my original. That's the pre-image, so we don't use prime notation. That's the original. And here's the copy or the image of that. So it reflected. So here's my starting point. I reflected it across the x-axis, and now here's my new location. So if I look at the coordinates of A has coordinates -4, -3. And let's see where it went to. So what are the coordinates of A prime? So A prime would be, if I go left 4, that'd be -4, +3. So -4, +3. And if I observe each value that I get, my x values, I can see did not change, right? Because if you're reflecting across the x, you can see that they both still have -4 as an x value for the points. And the next value was the y value. Well, I can see that here's my y value, and it became a +3. So if this is my y value, well, what's the opposite of -3? The opposite of -3 is +3. So if this is my original value y, the opposite of y would be -y. So you can see that this works. It doesn't matter which point you start or what quadrant you start in. Just think of this as saying that whatever your original point is, the x value remains the same, and whatever the y value was is going to now become the opposite. And you could try and test it out for other points, and you'll see that it's always going to work. And this only applies for reflecting across the x-axis. If you wanted to check if it works, how to reflect across the y-axis, you can do the same idea or the same setup that I created here, except instead of reflecting across the x, you reflect across the y, and you could observe what would happen if you were to reflect across the y-axis. So if you ever come up with this question, do like I do. Just draw a sketch and then observe, and then that can help you recall what the rule is. So you don't have to memorize this rule. You could just observe what's going on and then use that to come up with your answer.